Hello everyone. In this video we will learn about the formulation of LPP, that is linear programming problem for manufacturing or product problems. And also we will learn how to find out the solution of that problem. What are the product or manufacturing problem? First we should understand that. Suppose there is a factory or a firm producing or manufacturing some different two types of items. Then we are to find out the maximum profit on that particular items. How many items we should produce in a day to get the maximum profit according to the space available or profit per unit, manpower required or the machine hours, etc. Sometimes we have to produce two types of items according to the available quantity of the raw material. For that we have to formulate the LPP and then we have to find out the solution. This type of problems are known as manufacturing or product problems. What will be the algorithm to formulate the LPP and to find out the solution? Let's understand that. The number one, we have to understand the problem. And then we will consider the number of the items or the products which are produced or manufactured by the firm, by the factory as X and Y, the variables. Then we will formulate the LPP to consider the objective function, whether it is to maximize the profit or maximize the number of items produced. The constraints according to the given conditions, that are the inequalities, and then the non-negativity constraints, that will be the formulation of the LPP. And then we will draw the graph of the constraints, try to find out the feasible regions, and then the corner points. Then we have to find out the different values of the objective function z at different corner points, and then we will find out the maximum profit or maximum number of objects which are required. It means we have to find out the maximum objective function, and also we have to find out what should be the required number of items to be produced in a day to get that particular objective function. We will discuss now some of the problems based on the same. We discuss now one example, and that is a manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts. It takes 3 hours on machine A and 1 hour on machine B to produce a package of bolts. He earns a profit of rupees 17.50 per package on nuts and rupees 7 per package on bolts. How many packages of each should be produced in a day to get maximum profit? If each machine operates for 12 hours a day, what we do in such problem? What is to be found? We have to find out how many number of nuts and bolts packages are to be made. So we consider that to be X and Y. But before going to format or before going to the formulate the LPP, we make a table for this particular problem to understand the problem. That is, we are writing here items, they are nuts and bolts, the packages of that. Machine A and machine B, and then we write the profit, how much we are gaining. Here it is that nuts require 1 hour on machine A and 3 hours on machine B, and the profit for that is rupees 17.50 per package. Same here for bolts, 3 hours on machine A and 1 hour on machine B, and rupees 7 per package is the profit on this. The total time maximum for a machine is 12 hours each. So after writing this particular thing in a table, we are not to read the question again, everything is available here. And now we have to find out x and y, that is the number of nuts and bolts. So we consider, let the number of packages of nuts be x and that of bolts be y. Now we can see here 1 R is required for one package. So X packages require X Rs. Here it is 3 X Rs of machine B. Same way here 3 Y Rs on machine A and 1 R or 1 Y Rs on machine B. So what we will do? What is our motto? The objective function, that is to find the profit on these packages which we are forming. X packages of nuts and Y packages of bolts. So the total profit on that will be 17.50x rupees plus 7y rupees. So that is objective function. We write here objective function maximize profit Z equal to 17.5x plus 7y. Now the constraints. In constraints what we find here? Machine A, x Rs plus 3y Rs, that is always less than or equal to 12 because the maximum capacity of the machine A, that is maximum time for operation for machine A is 12 hours. So on the inequality, the constant here comes x plus 3y is less than equal to 12. Same way for this, 3x plus y is less than equal to 12. These are the two constants. And then the non-negativity constants, because x and y we are manufacturing. So x and y both have to be positive. So that is x is greater than equal to 0 and y is greater than equal to 0. This is the way we can formulate the LPP for the problem, and now we will go for the solution of it. After formulating the LPP here, we draw the graph of it. For drawing the graph, what we have to do? For inequality 1 and 2, we find the corresponding equations. Corresponding equation to 1 is x plus 3y equal to 12. If we divide by 12 to convert into the intercept form, this is x upon 12 plus y upon 4 equal to 1. The points of intersection on the x and y axis are 12, 0 and 0, 4. We plot the points here 12, 0 and 0, 4 and we join the line for this equation. For the inequality, we find 0 plus 0 is less than equal to 12. It means origin satisfies the inequality. So origin lies in the region of solution of this. Corresponding equation to 2 is 3x plus y equal to 12. To convert into the intercept form, we divide by 12 and we are getting x upon 4 plus y upon 12 equal to 1. The points of intersection of the x-axis and y-axis are 4, 0 and 0, 12 respectively. We plot the points 4, 0 on x-axis, 0, 12 y-axis, join it to get the solution of this. Then we find 0 plus 0 is less than equal to 12. It means origin lies in the solution region of this inequality also. So we are marking towards the origin. It means the common region, that is feasible region of this, will be OABC. OABC is the feasible region. And the corner points of this are ABC. O is not taken because this is x and y both 0, which is not possible. So A is 4, 0. B is, we can see from the graph, it is 3, 3. And C is 0, 4. Now we make a table to find the value of objective function z at different corner points. At point A, we are finding x is 4, y is 0. So the value of z becomes 17.5 into 4 plus 0, that is 70. At B, it is 3, 3. So 17.5 into 3 plus 7 into 3, that comes equal to 73.50. And at C 0, 4, this is 0 into 17.5 is 0 plus 7 into 4, the sum is 28. The maximum profit we are finding is 73.50. So we write here the maximum profit is 73.50 rupees. And at what points? There will be only one point, that is B, at which we are finding the maximum value 73.50, and the coordinates of B are 3, 3. It means the value of x is 3 and that of y is also 3. And we have here x is representing the number of packages of nuts, that is 3. Y represents the number of packages of bolts, that is 3. So for getting the maximum profit, we have to produce 3 packages of nuts and 3 packages of bolts, and this is the answer to the problem. This is the way we can find out the solution of a manufacturing problem. Now we discuss one more problem, and that is one kind of cake requires 200 gram of flour and 25 gram of fat, and another kind of cake requires 100 gram of flour and 50 gram of fat. Find the maximum number of cakes which can be made from 5 kilogram of flour and 1 kilogram of fat, assuming that there is no shortage of other ingredients used in making the cakes. To understand the problem, we make a table so that the complete information comes here. There are 2 types of cakes, first kind and second kind. What they require? Flour and fat. The first kind requires 200 gram of flour and 25 gram of fat. Second kind requires 100 gram of flour and 50 gram of fat. And the total flour is there available is 5 kilogram. It means that is 5000 gram. Total quantity of fat is 1 kilogram, that is 1000 gram. What is to be found? We have to find the maximum number of cakes which can be made. So we consider the number of cakes of first kind X and that of second kind Y. And then we form the LPP, objective function. What is that? Maximize Z, that is the number of cakes. It means that will be X plus Y. What are the constraints? Here we find the flour required by first is 200 gram, X number, it means 200X. And this is requiring 100 gram, Y cakes 100Y. So this will be 200X plus 100Y is less than equal to 5000. If we simplify this dividing by 100, we are getting 2x plus y is less than equal to 50. This is first constraint. The second one, 25x plus 50y less than equal to 1000. So this is 25x plus 50y less than equal to 1000. If we divide by 25, we are getting x plus 2y is less than equal to 40. This is second inequality for the constraint. Because we are requiring to make the number of cakes, that has to be positive. So non-negative constraints are x is greater than equal to 0, y is greater than equal to 0. And now we have to do the graph and find the maximum number of cakes. After formulating the LPP, here we go for drawing the graph. For drawing the graph, we have to find the corresponding equation to in equation 1, and that is 2x plus y equal to 50. To convert it to the intercept form, we divide by 50. And we get here x upon 25 plus y upon 50 equal to 1. It means the points of intersection on x-axis and y-axis are 25, 0 and 0, 50 respectively. We plot the points here 25, 0, 0, 50 and join the line to get the solution or graph of this particular equation. We find here 0 plus 0 is less than equal to 50, satisfying the inequality. It means this is towards the origin, so origin is included. This is the solution region for this particular inequality. Corresponding equation for the second one, that is x plus 2y equal to 40. Dividing by 40, we get the intercept form as x upon 40 plus y upon 20 equal to 1. It means the points of intersection on x and y axis are 40, 0 and 0, 20. We plot these points, that is 40, 0 and 0, 20 here. Join the line and we find here that 0 plus 0 is less than equal to 40. So origin is included in the solution region of this. And hence we find the common solution, the feasible region is OABC. And the corner points other than the origin are A is 25, 0. B we get from the graph as 20, 10. And C is 0, 20. Now after finding the corner points, what we have to do? We have to make a table to get the values of Z at different points A, B and C. So we draw a table, corner points A, B, C, values of x and y for them as 25, 0, 20, 10 and 0, 20. Then the values of Z, that is x plus y, are coming here. 25 plus 0 is 25, 20 plus 10 is 30 and 0 plus 20 is 20. So what is the maximum number? Maximum value is 30. It means the maximum number of cakes which we have to produce is 30. In that the first kind of that is 20 and the second kind is 10 because x is 20 and y is 10. This is the way we can find the solution of this type of problem. After understanding about the manufacturing problems, in the next video, we will discuss about the formulation of LPP and the solution of diet problems. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.